Hello everyone, myself I'm Akash Reddy from SVC College, Bangalore. So today's topic is about genetic algorithm. So let's go through the basics of genetic algorithm. Introduction. It is a search-based optimization technique based on the principle of genetics and natural selection. It is frequently used in find optimize or a near optimal solution to a difficult problem which are otherwise would take a lifetime to solve. Nature has always been a great source of inspiration to all mankind. Genetic algorithms are such based algorithms inspired concepts of natural selection and genetics. Genetic algorithms are based on the principle of selection, crossover, mutation, and few more. This is the basic terminology points. At first, we have the population. It is a subset of all the possible solutions to drive a problem. Chromosome. It is a one of the solution to give a problem. Gene. It is one of the element of the position of a particular chromosome. So this is the basic flowchart of a genetic algorithm. At first, it follows bottom top-down approach, population initialization, fitness function calculation, crossover, mutation, survivor selection, terminate and return best. At last we have the result. At first we have the population initialization. The genetic algorithm starts by creating an initial population of a potential solution. Each solution is represented as a chromosome, typically encoded as a string of binary digits. The population size and the chromosome representation are critical parameters in a genetic algorithm design. We can see in the image that it is represented in a string format, that is a bit. That is a different problems. Next, we have the fitness evaluation. Another fitness evaluation, it is a second one. The fitness function evaluates how well each solution performs in solution. Solutions with the higher fitness values are more likely to be selected for the reproduction. The fitness function guides the genetic algorithm towards finding an optimal solution. Next, we have the selection crossover mutation. Yeah, here we have the selection. In this selection phase, individuals from a populations are chosen from a reproduction ba- based on their fitness. Solutions with a higher fitness have values have a higher probability of being selected. Different selection strategies such as a roulette wheel selection and tournament selection are being used in the selection process. Next, we have the crossover process. Fifth phase. Crossover is a genetic operator that combines genetic information from two parent solutions to create a new spring offspring. The crossover point determines where the genetic material is exchanged between the parents. This process is introduced diversity in the population and helps explore a new region of solution space. At last, we have the mutation. Mutation is a genetic operator that introduces a random change in the offspring genetic material that is shown in the image. Before there is a incoming UV photon. Next there is a change in the code, that is a DNA form. It helps prevent premature convergence by maintaining genetic diversity in the population. The mutation rate controls the probability of a gene being altered in the offspring. At last, we have the reproduction result. After selection crossover mutation, the offspring replaces the least fit individuals in the population. The new population is then evaluated using the fitness function to determine the next generation quantity. This process continue until the terminate condition is met, a particular condition or result is met, such a maximum number is generations. Let's go to the advantage of a genetic algorithm. Doesn't require any derivative information. It is faster and more effective as compared to a traditional method. Has a very good parallel capabilities, optimize both continuous and discrete function and also multi-objective problems. Provides a list of good solutions and not just a single solution. Let's go to the disadvantages of genetic algorithm. It are not suitable. These are not suitable for all problems, especially problems which are simple and for which the derivative information is always available. Fitness value is calculated repeatedly, which may be computationally expensive on some problems and which may consume more time. There are no guarantees on the optimality or the quantity of the solution. If such if start implemented properly, the genetic algorithm may not converge to an optimal solution. Next, we have the applications of genetic algorithm. Genetic algorithms are used in various fields, including optimization, machine learning, and computer science. They are applicable to problems like scheduling, routing, machine learning model optimization, and game playing. Game playing like chess. Genetic algorithm can find a solution to a complex problem where traditional optimization technique may struggle. So, thank you. At last, we have the conclusion. Genetic algorithms are powerful optimization technique inspired by a principle of natural selection evolution. By leveraging selection, crossover, mutation, genetic algorithm can find a quantity of solution to a complex problem. Understanding the key components and parameters of a genetic algorithm is essential for designing effective optimization strategies. So these are the concepts under the genetic algorithm.